Hello, everybody. Welcome to our new webinar. I see people are still connecting, so perhaps we have to wait still 1-2 minutes more. In the meanwhile, let me tell you some rules of the webinar. Okay, all the microphones and cameras have to be disconnected. Really important. We are going to fix the presentation in the screen so that you can follow it easily. Anyway, if you have any doubt, please use the chat that you have available here in the application. Okay, you can type there your questions, and me and my colleague Ander Pradera from application department will be here answering you all your questions during the presentation. Anyway, if you have any further questions at the end of the presentation, we are going to be open to open again, to connect again the microphones. So please raise your hand, and if you have any question, I will connect again your microphone so that you can ask us directly. Okay, if any question has not been replayed during the webinar, don't worry, we will send you an email with your question and a proper answer after the webinar. One more thing, yes, really important, I would like to remark that this session it's being recorded, so if you want a copy of the video, please feel free to ask us by email. And one really important thing for us, during the presentation, we are going to launch a brief survey with few questions. So if you are so helpful to answer these questions, will be really appreciated for us because your feedback is really important for us. So please answer this survey before leaving the webinar. We wait 1-2 minutes more. Roberto, you can proceed to share the presentation. Yes. If all of you can see the presentation, please type it in the chat. If everything is okay for you, please type it in the chat so that we can proceed further, please. Okay, I see that you can see it well. Okay, good. It's working well. Fine. Well, first of all, let me introduce myself. My name is Javier Fernandez, Sales Area Manager at Fanox, and by the hand of my colleague Roberto Fernandez, Application Engineer, we are going to be talking during next 1 hour, more or less, about renewable energies. Mostly, well, we are going to introduce the relays, the protection relays that we are currently supplying for this application, mostly self-power relays. We are going to try to explain their characteristics and why we are using this type of relays for this application. We are going to focus our presentation into 2 markets, wind power market and solar market. And then we are going to finish with a brief explanation about new market trends, new challenges and solutions. So, Roberto, if you are ready, I think that in 1-2 minutes more, or when you want, you can take the control and start with the presentation. Okay.
Thank you very much, Javier. Okay, I think we can start. We have almost everyone also already connected. So, we are going to talk about renewable energies and how our relays can help you to integrate all these energies in the grid. So we are going to make just a small introduction to the renewable energy and the protection requirements that they have. A small reminder about self-power relays and the added value that this kind of relays can have to these protections. As Javier told, a small talk about wind market and the protections, as well as photovoltaic market and the protections. And finally, just a small view about the market trends, the new challenges that are arising on these markets, and the solutions that we are developing in Fanox to cover all these challenges. At the end, question and answers for any doubt that can be from your side. Okay, so as all you know, renewable energy is derived from infinite natural resources sunlight, wind, waves, tides, also geothermal, and they are becoming more and more important. And the integration on the grid is having new challenges for us. It has been a paradigm shift. That means that till now, most of energy has been produced in a centralized point and from non-renewable energies. And from that spread to all the territory to give enough power to all the industries.
Sorry, Roberto, could you change the way of the presentation? I mean, to show just the slide. I mean, because we can see.
Okay, just let me see if I can share the correct one.
Yes. And change I think that.
Now it's just the.
Yes, we can see it well.
Okay. Okay, perfect. Thanks. As I was saying, there was a paradigm shift because now the resources are decentralized along the territory. So the renewable energy has going to a distributed energy generation network. It means that we are not having just one point and from that giving energy to all the consumers. If not, we are having more small, several generation points all around the territory, and the connection between them and the integration is becoming something much more important. So in this situation, we can distinguish two types of protections. The first one is the protection for interconnection to the grid. All these farms, wind farms, solar power plants, needs a substation transformer and an integration to the grid. This we will have just a few words at the end of the presentation. And on this presentation, we're going to be more focused on the protection inside those farms. So what you can see on the slide is the transformers T1, T2, T3, Tn that are inside the wind turbines or the solar inverters. Here we can see, just to show you a portfolio of Fanox. We have, as you can see, we have products for all the steps of the production energy, but in this presentation, we're going to focus on the overcurrent and earth fault relays. This, as I said, this is going to be for the protections inside the wind farms. And specifically, we are going to talk about self-power relays that we think that can give us something much more and advantages regarding traditional relays on this kind of connections. Just a reminder, I'm pretty sure most of you have assisted to our previous webinar about self-power relays, but in case you didn't, or just remember, what is a self-power relay? Traditional relays needs an auxiliary power to be powered. It means that in some locations where this kind of power cannot be assured, or even in events that make the UPS system or the auxiliary system going down, these relays will be useless. For this reason, the self-power relay doesn't need an auxiliary voltage because it takes the energy directly from the cities that are connected to the lines. It means that the relay, as there are any current flowing on the system, the relay is going to be powered up and is going to have the energy with all the functions will be working properly. So how do you get this power from the lines? In Fanox, we have two options for these transformers: the standard transformers, 1 or 5 amps on the secondary, and also specific transformers. These transformers are not standard ones, but they have a higher saturation level, which give us a much bigger measurement range, and it has some advantages, as we're going to see on the next slides. The other issue is how we trip the circuit breaker, because usually a coil requires a lot of energy that without this auxiliary power is not possible to operate. However, as these relays need to take care and a good management of the energy, a low power coil is required. This is a device that is a biostable that is activated with the energy that is provided from the self-power relay. That's why we don't need any auxiliary power, because also the 3-pin circuit will be operated with the energy of the self-power relay. This striker of low power coil is a bistable, and they have different activation levels, 12, 17, 22, 24 volts, and our relay covers all of these voltages on just changing the settings of the relay. Okay, so now we are going to start with wind power energy. Our relays has been installed and is working as main protection for the generator, or also as a backup for the bigger or more complex relay that is having the first step of protection of the generator. But the self-power relay acts as a backup. It goes be inside or outside the windmill. And what are the advantages of these self-power relays? As you know, depending on the market practice, on the kind of turbines and generators connected to them, and the impact on the network stability, there are different approaches to the management of the wind farms. With traditional relays, as I said, any failure on the power supply can imply either the stop of the turbine or a non-protect generation scenario. This doesn't happen with self-power protection. This self-power protection, if the turbine is working and generator is working, the relay will have enough energy to energize itself and to trip if necessary. This is especially important when you have some strong requirements on backup protections, but also it's important for different kind of turbines, mainly turbines type 1 or type 2, that have a less, that requires less control during the energization. These relays can cover all this protection that they need. This is the portfolio of self-power relays from Fanox. As you can see, we have a CAC that works with the standard CTs, /1 or 5 amps. All of our self-power relay has remote communications, Modbus or EIC 103 or DNP3, and all of them are self-power, but also have the option to have an auxiliary power supply. They have different self-powering levels depending on the CTs and the relays you are choosing for your application. And also you can see the different protections that are available for each one. All of them also, again, have configurable inputs and outputs. And you can see just a small picture. We're going to go through them during this presentation. We have separated these relays in this presentation on wind farms and photovoltaic farms, but it's important to remark that all of our relays are being used in all this kind of connection and renewable energy, okay? We have a split in two just to give us, just to give you an idea of what are the most successful relays. But again, all of our self-power relays are used in both applications, okay? The first one is our SIA-B with specific CTs. We have different mechanical adaptations, horizontal or vertical, depending on what your requirements in terms of size are for your circuit breaker. And as you can see here, this is the main protection functions. We have overcurrent, head fault current. We have an external trip and thermal overload, and also second harmonic blocking, as well as trip block, and if necessary, some logic that can be achieved during the configuration of this relay. These relays, I told you, is working with the specific CTs. That means that there's a high saturation range. So for example, if you choose CT32 tape, the nominal current of the system that it can control is between 12 and 130 amps. That means these CTs can be used to standardize the engineering part. So you can use the same relay with the same CT for a wide range of installation with different nominal power and currents. This is very helpful because you have to do the engineering. Also, it has some advantages in terms of stock and warehouse components. It's important to remark that relays have a self-power value from very, very low currents. So as you can see here, from 3.2 amps, our relay will have enough energy to be awake and to trip if necessary. One important thing that this relay has is a second harmonic block protection. This is something that is not very common on this kind of relays, but it's very important, and it's becoming more and more important as the size of the turbines of the solar inverters is becoming bigger and bigger. So the protection that they need, the inrush current during the energization of the transformer is becoming higher. On this situation, it's very important to distinguish when there is an energization of the transformer and there is an actual fault. With this protection function, based on the detection of the second harmonic on the current wave, we can distinguish these two situations and avoid unnecessary tripping during connection of the transformers. It's important to note also that we have, of course, the local communication to make all the parameterization of the relay through a micro USB port with a Modbus RTU protocol, but also we have a remote communication that is available in self-power mode. I mean, you don't need auxiliary voltage, auxiliary power to have this kind of communication. And it's becoming, again, more and more important because the SCADA system and the control systems requires communications between all the points of the substation, of the farm. So again, it's important to have it in self-power mode. There is another issue, the two more important features that we have up to 2 configurable outputs, plus the dedicated trip output for the low power coil and an external trip input, which works without with no need for external voltages. That is very, very important. It's a free potential contact. You just need oil temperature indicator from transformer or any other device that can close a contact, and the relay will trip instantaneously. Again, we have true frontal LEDs for indication and one magnetic indicator also. Of course, an LCD and HMI to check and parameterize the relay with a commissioning battery. So you can go to a complete unpowered substation and just with the commissioning battery, check if the relay is working and check the settings, configuration, and so on. We have regarding storage of the events and faults. We can storage up to 100 events and 4 fault reports. And they are going to keep in the memory because they are storage in a non-volatile RAM memory. And again, the time and date are fixed with the real-time clock. Also, we can have a self-diagnosis output configured or watchdog. That is a very important requirement for most of our clients. This specific relays has a very compact size and is easy to install. And as I told before, it's the combination between this relay and the CTs can give you a standardized engineering and cost saving benefits. We have a very fast switch on to fault response below 90 milliseconds. Just a small reminder, the switch on to fault response means that when the relay is completely power off, switch off, and then a fault occurs, the relay takes 90 milliseconds to woke up, detect the overcurrent, and trip the relay, and the circuit breaker, sorry. This is also a very important parameter regarding self-power relays. We also have on this relay an anti-corrosive treatment. As you know, this kind of renewable wind farms or solar farms are being located in different and strange positions. Deserts, tundra, close to the coast side. And for this has implied that our relays need to have a degree of protection higher than the traditional ones in the substation, okay? That's why we have developed in coordination with some of our customers, and we have passed successfully the salt fog test with severity 6 according to the ICO standard, and it's a test with 56 days of duration and with some defined characteristics of humidity and temperature. And our relay has been tested and passed to this relay, so it's completely approved to work on these more harsh environments. This one is the SIA-C relay with the standard CTs. As you see, the shape is different, and also the protection functions are much more complex. We have also the phase overcurrents and earth fault overcurrents. SHB, again, external trips, but we also have some protection functions that can be much more interested, like phase balance kind of protections. We have the monitoring of the circuit breaker, function 52, and reclosing device in case you need to reclose the trip and after some time reclose the production, the rest of the generator. And we have some control functions like phase CT supervision, trip voltage supervision, and even the circuit breaker failure. The characteristics of this relay is that it works with standard current transformers, and the self-powering level is very low. It means that we can overact the relay starting from 0.1 times the nominal current. That means if you have a 40/1 amps CT, we are going to power up the relay starting in 4 amps on the primary side, okay? As I told before, we also have this local communication. In this case, it's a DB9 connector, also working with Modbus RTU protocol, and the remote communication also available on self-power mode through our ERAS 485 port. And in this case, we have Modbus or EAC 103 protocol. We have 3 configurable outputs and up to 2 inputs, and external input, and the trip output for the low power coil. We have more indicators on the front of the relay, 3 frontal LEDs, up to 3 magnetic indicators, and also we have backlight option for the LCD, which can be very useful depending on the situation and on the placement of these relays. Also, it's available to commission in battery, and again, of course, LCD and HMI to check and parameterize the relay. Regarding information storage, this relay has up to 1024 events and 24 reports. And depending on the model, also we can have 10 oscillography records in ComTrade formats, which is a very useful indication and helps a lot to study and check what the faults and the reason of the fault have occurred in a particular situation. There is something important on this relay, that is we have also 4 setting groups, 2 levels of overcurrent protections, again, second harmonic blocking and reclosing capability. It's very important to have different setting groups, because depending on how you energize or you first commissioning of the devices, you may have two separate setting groups, one for normal behavior of the installation, second one for the maintenance purposes, and maybe a third one to allow some overcurrents or during the first energization. And you can change easily between these three of setting groups with separate setting groups by means of with inputs with a selector. It's something that gives us more flexibility to our relay to cover all of these situations. Now we're going to move to solar power, to the photovoltaic market. And our relays are typically installed on the medium voltage cell as the protection for the stepped-up transformer, the solar inverter. And depending on the size and the complexity of the project, we have two different approaches. The first one is self-powered relay, for all the reasons we have spoke before and some that are going to see now. But as the size increase and the complexity of the project is becoming bigger and bigger, we have they require a protection relay with the protection functions and the capabilities of a traditional feeder protection. And we are working on those two different ways. As I said before, there is also a tendency on the solar market, on solar power, that the solar inverter is becoming bigger and bigger. As this power increases and this voltage is rising, the market is not demanding the traditional overcurrent protections, but full data register, protection and control functions with closing capacity, advanced communication, as we said before. So from Fanox, we have working in two directions. The first one is to try to evolve one of our relays to a complete self-power relay that works with extremely low self-powering level, has a very compact design, has a channel for the neutral current, which means that you are working with a measured current in the neutral. It has oscillography record and a full range of curves for selectivity, EIC and EEE, second harmonic blocking, so on. However, if the requirements goes to advanced communications, TCP/IP protocols, EIC 61850, we are going to a relay that is not self-power, but has all these capabilities, as we are going to see next. This is a SIA-B with the standard that works with the standard CTs. The main difference, as you can see on the layout, is a very compact relay, and it has not only the traditional overcurrent and airflow protections, but again, second harmonic blocking for load pickup, monitoring of the circuit breaker failure, trip block, switch disconnector, and it's also possible to have a zoning selection interlocking with the inputs, outputs, and communications. As said before, it's a self-power relay, but it's also dual power. It means you can connect it to auxiliary power, and it works with standard CTs with 1 amps on the secondary. It's very important that the requirements for energize this relay is less than 2 VAs, which means that the CTs that you are going to connect to this particular relay has a very compact size. And the source power is from 0.075 times the nominal current. As you can see, it means that it's going to be ready for operation for a very low power on your installation. Also, as all of our self-power relays, we have local communication through a micro USB connector and a remote communication with Modbus RTU or the MP3, but also it's available on self-power mode. Regarding storage of the events, we have 10 oscillatory records in ComTrade format, 1,024 events, and 24 reports. And of course, we maintain that an hour thanks to the RTC. Also, you can configure a watchdog, an output or alert to have this indication on your installation. It has a very compact size and easy to install, lightweight, and cost saving. In this case, in terms of the front of relay, we have four frontal LEDs with LCD and the HMI to check and parameterize the relay, and also a commissioning battery. In this case, we have 3 inputs and 3 configurable outputs, plus the trip output for the low power coil. In the same way that the previous one, we have up to 4 setting groups, 2 levels of current protection, second harmonic blocking, and also load data profiling depending on the model. Regarding protection relays that are not self-power, we have our transfer feeder protection relay that has, again, all the protections functions over current and air fault, with some special issues like switch fault to fault, phase balance current protection, broken conduction, undercurrent, second harmonic blocking, of course, monitoring of the circuit breaker, control functions like the circuit breaker failure and trip circuit supervision, as well as reclosing device, trip block for the switch disconnector, and so on. This relay has an universal auxiliary power supply, and it works with 5 or 1 amps on the secondary, standard transformers again. We have also an option to have short-circuitable current terminals that work with a secondary of 1 amps. It's not, despite it's not being defined as a neutral, sensitive neutral, or this kind of name on the relay, the measurement is so sensitive that we can measure from 10 milliamps on the secondary. Okay, so despite it's not being defined like that, the sensitivity of the relay is very high. We have also, important for some applications, a restricted air fault protection. And regarding the events recording, we can go up to 100 oscillography records in ComTrade format, 3,072 events, and 24 reports. As you can see, the storage of this relay is much bigger than the previous ones. And we also have up to 6 inputs and 6 configurable outputs with a configurable frontal lens. Again, LCD and HMI to check and parameterize the relay. We also have available 4 settings groups, and the biggest improvement or the biggest difference this relay relation with the self-power relay is that we have advanced remote communications. It can be an RS485 port with Modbus, EIC, or the MP3, but we also have TCP features through Modbus, the MP3, EIC 104, or EIC 61850. Another important issue is that we have reclosing capabilities, and we have an extended logic that allows to implement complex control schemes, as we have done in the past with some of our clients, and to more complex situation in combination with other devices that can be installed on the park and give information to this relay, and this relay make these complex control schemes. Regarding these installations of wind markets and solar and photovoltaic parks, these are the relays that we are currently installing. However, the new challenges that is renewable solar and wind parks are bringing to us, and it has these effects on the grid. On the HV net, if they are connected to the HV network, as the amount of renewable energy are increasing, we are having less traditional power plants, which means less inertia, less frequency, voltage, and power balancing support. And as the inverters and the wind farms are becoming bigger and bigger, we have more power supplies without rotational inertia and with a variable nature. The problem is that the HV network capacity constraints may become an issue. And if these farms are connected on the NB network, again, these inverters with less rotational inertia and with variable nature make that the traditional protections of the NB system and this landing detection may mal-operate. How to manage those impacts? Until now, the distributed generation unit has been required to disconnect during utility grid faults. That means if there is a disturbance in the frequency of the HV of the MB network or in the voltage, these renewables sources were required to disconnect, leave these traditional power plants, recover control of the network, and after that, connect to the network again. However, nowadays, as the impact of these renewables energies are becoming bigger and bigger, they need to contribute to the stability of the system. For that, new protection and control schemes are required to prevent unnecessary disconnection during faults on the HV and MB networks, but also they have to be available of give support during this disturbance regarding voltage and frequency, injection of reactive power. So these control schemes need to be much more complex, and they need to take into account not only voltage, frequency, but also power, the active power, reactive power, and mix them with the control of voltages and frequencies. For those impacts, Fanox has been giving a second steps with a more advanced, with a restructuration of our relays, and we are working on the integration of these wind farms with the traditional grid lines HV and MV. For that, we have these relays, that second generation of relays, SIA-A and SIL-G, that can work as these interconnection systems to the grids. Both relays has a complete set of protection functions: overcurrent, air fault, with all the direct and undercurrent. We also have arc flash to detect the important. Okay, just a small stop here. We have launched, as Javier told at the beginning, we have launched a survey on the relay list on this presentation, and we will appreciate if you can fill this survey. It just takes 20 seconds of your life when we are finishing this presentation. As I said, this has overcurrent protection as well as voltage protections, and the frequency, undercurrent, overcurrent, and rate of frequency, and power control. These relays comes with a complete set of communication protocols: Modbus 103, 61, 850, and also can be in a different media: Wi-Fi, RS-45, fiber optics. Again, a complete storage through COM phase and events of all registering. And the main difference between these two relays is that the C-Ray has 4 current channels and up to 6 voltage channels, but it works with sensors, both capacitive and resistive. It also has recloser functions, access analyzer or sequence coordination. And the SIL-G, as is intended to work with generator, but it's also can be very useful on this situation, have 4 current channels and up to 5 voltage channels, and through voltage transformers, the traditional voltage transformers. And we have also some functions that are very particular for generators, like overfluxing. But these relays are going to be subject to next webinar, and all these applications and how to complete definition of them is going to be shown on that webinar. And here are just some references that where we have been installed our relays from ABB, Evera, Schneider, Siemens Gamesa, Eaton, General Electric, Acciona, and also solar references with Iberdrola, CEL, HEMA, FSX, Siemens, again, INGTM, and General Electric. And here ends our presentation. So Javier, if you are here.
Yes, Roberto.
Okay.
We have been answering here in the chat some questions. Most of them regards to this directionality function in solar application. Okay, the 67 for neutral. We have something, we are working on it, and also about the oscillographic records. Okay, in self-power relays, if they can be configurable or not. I don't know if you can advise us.
Okay, just one step.
Yes, about the directionality.
Regarding the directionality, as you know, as the power plants, in this case, wind farms and solar farms, are becoming bigger and bigger, and the interconnection between all these brands that goes to a collector point, and then we can have several bars to connect to the main grid. The requirements of the protections are becoming more close to a traditional distribution system. And in this case, it's for a 67 for a directional overcurrent protection is needed, because to prevent and to make the coordination of the protection and the selectivity to check where the fault is and which part of these brands we need to disconnect. That's why the requirement of the 67 is required. Actually, we are speaking, our R&D department is developing the directionality also in safe power relay. It has some issues because we also need to have to detect the voltages. So it's taking some more steps forward and improvements on the relay capability. However, the first thing that we have detected on the market as a requirement is the option to have the directionality on the neutral overcurrent function, 67N. And on this one is something that we are working on as first step for self-power relay.
Okay, one more thing is that they ask us is if self-power relays has remote communication, okay? If we have it with the need of auxiliary voltage or not.
Yes, as I said during the presentation, all of our self-power relays has the remote communication available in self-power mode. You don't need auxiliary power to have to communicate with the SCADA and the relay and so on. If there is energy on the lines, the relay will have that ports available and these communications available?
Yes, this is for all our mates here in our webinar. It is your time. It is your time. Please raise your hand and ask directly to Roberto so that we can answer you. If you have any question, please raise your hand. You have the icon here, and I will connect your microphone so that you can talk directly to Roberto. So come on, this is the time. Anyone?
No one? Okay, I don't know if I explained everything so clear that no one has any question, or if it was so boring that anyone has a question.
Yes, I see questions in the chat, but please come on. This is the time to ask it. Well, with live voice. So yes, Conrado is asking us if we have ready libraries in ETAP software.
Well, we are working with that app to have the models of our relays. Right now, I think they are ready for working with them as SIA-B relays. Unless we have provide them all the information that they were required to insert our relays on the software.
Okay. Also, I would like to remark that this presentation, this webinar, is being recorded, so don't worry, we will send you the video. They are asking us if 61850 is available in SIA-C model in self-power relay right now.
Right now, no, because in SIA-C relay, as I said, it's a self-power relay, and at this time, our self-power relay doesn't have option for advanced communication protocols. So anything that requires Ethernet or TCP/IP connection is not available at this time, at least.
Yes, it's not available due to the consumption of the advanced communication right now, and as you know, the self-power relays, the energy is really scarce, and we have to handle these few levels of energy. Yes, they are also asking about Wi-Fi in self-power relays.
Well, with Wi-Fi, we have we are in the same situation that with advanced communication. As these relays, the management of the energy on these relays, it's something critical. We cannot have these kind of features on self-power relays. So it's not a matter of technology. It's a matter of how we manage the energy to have to wake up the relay, to have enough energy to power the relay, and to trip. We cannot have a consumption that requires this advanced communication or Wi-Fi taking energy from our relay. So at this time, sorry, it's not possible to to have this communication on our relays.
Yes. Do you have any other question? Yes, they are asking us about second harmonic blocking, about a few technical explanation. Well, they are asking us to share some technical explanation, some technical documentation, but if you can give a brief explanation on how it works.
Yes, yeah, sure. During the energization of the transformer, there is an overcurrent. This overcurrent is due to the magnetic circuit of the transformer, and when you energize the transformer, this overcurrent has is particularly rich in a second harmonic of the wave shape. For example, if you are connecting to a grid of 50 Hertz, you are going to have a 100 Hertz wave shape from the current. And this is the main difference between an inrush current and a fault, because during a fault is a normal 50 Hertz current wave shape, but during this inrush current, the second harmonic has a big component, and this second harmonic that the one that increase the value of the current. With the second harmonic blocking function, what we do is check on the current that is flowing through the CTs. What is the fundamental value? What is the second harmonic value? And with the settings of the function, we can stop the trip because the second harmonic component of the function of the wave shape is over 20%. Usually it's not a fault, it's an inrush of the transformer. So with that function, we distinguish between a fault and energization of the transformer, and we can avoid unnecessary tripping during reconnection of these transformers to the grid.
Okay, thanks, Roberto. Yes, they are also asking us about the meaning of switch on to fault. I don't know if you can extend a little bit the meaning of the switch on to fault concept.
Okay, the switch on to fault concept on the self-powered relay is as you know, the self-powered relay doesn't have an auxiliary voltage. So if there is not current flowing on the system, the relay will be switched off. The switch on to fault system indicates the minimum tripping time of the relay when a fault occurs with the relay switched off. So imagine you have everything switched off, you close the circuit breaker, and there is a fault on the grid that goes through your system. Our relay, depending on which one of our relays, can trip in less than 50 milliseconds. Okay, that means that the relay with the energy that is flowing is going to power up, is going to detect that there is an overcurrent, and is going to trip in all of this in less than 50 milliseconds. This is a difference with the traditional relays, because on the traditional relays, you have an auxiliary power. So the relay is already working. From that point of view, the self-powered relay works exactly the same that the traditional ones. If the relay is powered up and is working, the tripping times will be 20 milliseconds, or the ones you are adjusting on the protection functions. However, if the relay is powered off, it has to wake up and charge the capacitor for tripping the low power coil. We can do all of that in less than 50 milliseconds.
Okay, well, we are reaching to the end of the webinar. Anyway, first of all, thanks to all of you for coming and joining us during this webinar. If you have more questions, don't worry, we will be still here answering you all your questions. But first of all, thank you very much for coming to our new webinar. And yes, if anything has not been replayed during the webinar in the chat or right now, we will send you an email. You can send us an email directly to us, and we will reply you at the end of well, we think today, tomorrow, we will reply all the questions that has not been replayed yet. Okay, so as I said, thank you very much for coming. And of course, if you still have more questions, we will be here more minutes waiting for you and trying to reply you as good as we can. Okay.
Thank you very much, everyone.